and sharing the screen. Today we're going to look more at systems of equations. So far we've looked at solving systems, and we're going to again in this class focus on solving them algebraically. So to solve systems, we've got substitution, or that addition elimination method. Homework 8.1 involves solving systems of equations. Some they ask you to solve by addition, some they ask you to solve by substitution, and there are quite a few application problems, word problems, which we will be looking at. Before we get started, has anybody started looking at any of the homework? Does anybody have any questions on any questions? Or for that matter, does anybody have questions on anything that we did in the notes last time?
Yeah,
I have
did
a
you?
question.
Oh, you go.
Go ahead.
It's 3.1, number 4. I just can't. I'm messing up. I checked my answers after and I got it wrong.
Section 3, homework 3.1, question number 4.
Yeah.
Also, did you move the date of the upcoming homework?
Yes, I did.
Yeah, it was 16.
Where we were.
Okay, because I got on it was like disappeared for the week, and I was like, oh no.
Is that problematic if I gave you a little bit extra time on it?
No, I'm very grateful. Thank you.
Okay, for the coordinates of the vertex of a parabola, if we've got something in that general quadratic form, f of x equals ax squared plus bx plus c, the vertex is on the axis of symmetry, and the axis of symmetry is given by x equals negative b over 2a. So as I look at this, a, the coefficient on x squared is negative 1. B, the coefficient on x is 4. So negative b over 2a would be negative 4 over 2 times negative 1 would be negative 4 over negative 2, which is 2. And so that's the x value of the vertex, because it has to be on that, excuse me, axis of symmetry. To find the y value, well, if x equals 2, the y value is f of 2. So that would be negative of x is 2 squared, plus 4 times 2, plus 7. So that would be minus 4 plus 8 plus 7, which would be 11. So my vertex would be the point 2, 11.
See, that's exactly what I did for my question.
Uh-huh.
And when I checked it, they gave me a different answer. If I could just give you my numbers and we could go over it.
Give me sure. Let me just make, whoa. This is not letting me type it in. There we go. There's my keyboard. So we're saying that the vertex is 2, 11. So the point, let's use parentheses, 2, comma, 11, close parentheses equals, yeah. All right, so what was the equation that you were given?
F of x equals negative x squared plus 8x plus 4.
The axis of symmetry, when you took negative 2 over 2a, did you get 4?
Yep.
And so when you found f of 4, did you get negative 16 plus 32 plus 4, which would give you 20?
Right. That's where I messed up. I see that now.
And so it's
I had a positive 16.
No, order of operations, first you square it, then you negate.
Right.
Okay?
Thank you.
You're welcome. Any other questions from anybody else on anything else? I would strongly suggest that you folks start looking at that homework 8.1. So start with, today we're going to look at just a few more examples of solving systems of equations by elimination, by addition. And then we're going to, excuse me, look at application problems. So next example, where we're going to solve, I guess we could use the method of your choice. I'll let you guys pick. If I have the system x plus 2y equals 2, negative 4x plus 3y equals 25. Would you folks choose to solve this using substitution, using addition, or what?
Substitution.
Substitution? Okay, if we were to solve this with substitution, what variable would you solve for and what equation would you use?
Solve for x.
And so in the first equation,
Yeah.
x plus 2y equals 2. And so subtracting, we'd get x equals negative 2y plus 2. And so now in the other equation, negative 4x plus 3y equals 25. We're going to replace x with what we just said it equals. Negative 4 times negative 2y plus 2 plus 3y equals 25 would give me, don't forget to distribute, would give me 8y minus 8 plus 3y is 25. 11y minus 8 is 25. Adding the 8, we'd get 11y equals 33. And dividing by 11, we get y equals 3. Okay. Am I done?
Nope. Now you got to plug in the y.
And again, I would plug into that equation that we solved for
First one.
x equals negative 2y plus 2. So that would be negative 2 times y is 3 plus 2. So negative 6 plus 2 would give me x equals negative 4. So our solution would be negative 4, 3. Again, I would strongly recommend that you go through and check. But is everybody all right in the interest of time if we don't do the checks today?
Hang on 1 second. Why do you have negative 2y?
Here? Do you mean here?
I mean, when we were solving for x at the end, why
Oh,
is it?
I substituted into that equation because x is already alone.
Oh, okay.
You can
Okay.
substitute into any of
'Cause
the,
it's already in this. Yeah, okay. I see.
but I always find it's easiest if I'm using substitution to substitute into the equation that was solved for the other variable. I'm a slacker from way back when. Is it all right if we turn the page?
Yeah.
Yep.
Then next example. Let's look at the system. 2x plus 3y equals negative 16. And 5x minus 10y equals 30. This one let's solve using addition or elimination. And it doesn't make a difference to me. Would you folks eliminate the X or the Y?
X.
X. So to eliminate the X, since this has a coefficient of 2 and the other equation has a coefficient of 5, that first equation, 2x plus 3y equals negative 16, I would go through and multiply both sides by the 5. Be careful. Places where there are common careless mistakes, do it to both sides, not just, and make sure you distribute. So that would give me 10x plus 15y equals negative 80. Then my second equation is 5x minus 10y equals 30. I'd multiply this equation. If I multiply it by 2, this would give me 10x. I want them to be opposites, so I'll multiply by negative 2. That would give me negative 10x plus 20y equals negative 60. I want to stop for a minute. I want to make sure. Is everybody comfortable with the executive decision if we're eliminating x to multiply the first one by 5 and the second one by negative 2? And
I just, how did you choose those numbers?
well, since this one has a coefficient of 2 and this one has a coefficient of 5,
You just want one to be negative?
yeah,
Or cancel out?
multiply it by the other coefficients and you want them to be opposites. Instead, if I wanted to eliminate the y's, because this one's 3 and this one's negative 10, does it make sense to eliminate the y's? I'd multiply this equation by 10. In this one, I'd multiply by positive 3 and multiply them both by a positive because the signs are already opposites. Another careless mistake that I sometimes see is some people start by just adding the given equations. And if I were to just add those given equations, nothing would be eliminated, nothing would disappear, so it doesn't help me. But because we chose carefully the 5 and the negative 2, do you folks see now that the x coefficients are opposites? And so when I add down 10x plus negative 10x would give me 0x, so that the x's are eliminated or they disappear. I get 35y equals negative 140. Then to solve for y, we just divide by 35. And we get y equals negative 4. So far, so good. If so, we're not quite done yet. We have to find x. To find x, we're going to substitute, and we could substitute into any one of these equations. I think I'm going to use that first one, 2x plus 3y equals negative 16, just because I have a tendency to want to use the smaller numbers. That gives me 2x plus 3 times negative 4 equals negative 16. Or 2x minus 12 equals negative 16. If I add 12 to both sides, I get 2x equals negative 4. And when I divide by 2, I get x equals negative 2. So my solution would be negative 2, negative 4. And again, be sure to check in both original equations. Is that one all right? Not hearing any questions? And being lazy about the check, because I want to make sure we get to those word problems. Next example, let's have 6x plus 2y equals 7. And 3x plus y equals 2. It's a matter of preference. With any one of these, you can use substitution or elimination, addition. I have a tendency to use addition when everything's all lined up for me. But if you wanted to, this one isn't too difficult to solve for y. Does anybody have a preference as to whether we use addition or substitution?
Addition.
So if I use addition, looking at the fact that that second equation has a coefficient of 1, does it make sense that I might want to eliminate the y's? The first equation, multiplying by 1, would leave it alone. The second equation, I might multiply both sides by -2, which here distributing would give me -6x minus 2y equals -4. To that point, is everybody comfortable with the decision to eliminate the y by multiplying by -2? When I do that, though, do you notice that the x coefficients are also opposites? 6x minus 6x is 0x. 2y minus 6y is 0. So what's left on this side is 0. And what's left on this side is 3. And so I've eliminated my variables, and I've got this equation 0 equals 3. Is that true or is that false?
False.
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 And so this is one of those examples where, since it's false, the variables disappear and it's false, we're going to say that there are no solutions. The solution set would be the empty set. It's what we considered an inconsistent system. And again, what happens is, if I were to look at those two as lines, if I were to graph those lines, I'd have parallel lines. They don't intersect at all. And so go through, double check your arithmetic, double check your algebra. But if you end up with a false statement, there's no solution. And it does happen. Next example. Let's look at 4x minus 2y equals 2. And 6x minus 3y equals 3. Do you guys want to use substitution or elimination?
Elimination.
Elimination is, let's get rid of the y's. The numbers are a little bit smaller. This first one, let's multiply both sides by -3. The second one, let's multiply both sides by 2. That first product would give me -12x plus 6y equals -6. That second product distributing would give me 12x minus 6y equals 6. This time when I add, I get 0 equals 0. I want to look at that equation. Is that true or is that false?
True.
I've seen that. I've heard of days where the 1 p.m.
And since it's true, it means we have infinite solutions. It means we have a dependent system. It means that the two equations would give me the same line. So my solution set would be the set of all of the points on either equation. Since they're points, we'll say they're the set of ordered pairs x, y, such that, and then we're going to put an equation that shows the relationship. We can use any of them. I'll use that 4x minus 2y equals 2. I could just as easily have put the other equation because we've gone through and we've shown that the two equations are equivalent. They say the same. And so I know this would be the case where your two lines fall right on top of each other if you were to graph them. They turn out to be the same line. Is everybody all right with the difference between dependent, when you get the variables disappear and you get a true statement, and inconsistent, when the variables disappear and you get a false statement? If so, I took the liberty of pulling a bunch of other problems from the textbook that I'd like to add to the notes and look at. They're in this file here, word problems. And so I'm going to be lazy and I'm going to go through and copy and paste those into today's notes. And so the next one that I'd like to look at is this system of equations here. I've got x minus y over 3 equals x plus y over 2 minus a half, and x plus 2 over 2 minus 4 is equal to y plus 4 quantity over 3. Wow. Those look a little bit different, don't they? What we're going to do first is we're going to clear the fractions by multiplying both equations by the least common denominator of the fractions within the equation. Then we're going to put the equation in standard form. So let's start with that x minus y over 3 is equal to x plus y over 2 minus a half. And some of you folks, when we were solving the rational equations, you did all sorts of other manipulations. It's really a lot easier if you go through and you find the least common denominator of all the fractions within the fraction. So between 3 and 2, the common denominator is 6. But because it's an equation, rather than making each of those fractions get that denominator of 6, I'm going to multiply both sides by that 6. On the left, I get 6 times x minus y over 3, and I can think of that as 6 over 1. On the right, I have to distribute. I get x plus y over 2 times 6 minus 1/2 times 6. Is everybody with me so far?
1 second.
Now, you ready?
I'm just copying it down. 1 second.
If you choose
Good.
the right common denominator, 3 is a factor of 6. If I divide out that 3, that 6 becomes a 2, and I'm left with 2 times x minus y equals, over here, 2 is a factor of 6. 2 goes into 6 3 times. Leaves me with 3 times x plus y minus 2 again goes into 6 3 times 3. And doesn't that look a lot nicer? We'll distribute 2x minus 2y equals 3x plus 3y minus 3. Let's move all the variables to one side. I'll subtract the 3x and the 3y. And that'll leave me with the equation. I'm going to write it over here. Negative x minus 5y equals negative 3. That was so much fun. We get to do it again with that second equation, which was the x plus 2 over 2 minus 4 is equal to y plus 4 over 3. Here, the common denominator again would be 6. So I'm going to ask you folks to please multiply both sides by 6 and tell me what you get. Did anybody else for that equation get 3x minus 2y equals 26?
Still working mine out.
Okay, I'm sorry. I'll give you a minute. You guys have it?
Yep.
So now one system is negative x minus 5y equals -3. And 3x minus 2y equals 26. Let's solve that system by elimination. Let's eliminate the x's. Let me multiply the first one by 3 to get -3x minus 15y equals -9. The other one is 3x minus 2y equals 26. And you see how because the x's are opposites there, when we add, they're eliminated. I get -17y equals 17. And so dividing by -17, I get y equals -1. And then I guess I'll use it -x minus 5y equals -3 in order to find my x. -x minus 5 times y is -1 equals -3. Gives me -x plus 5 is -3. Subtracting -x is -8. So dividing x is 8. And my solution is 8, -1. With this one, I'd like to do the check. So I'm going to cheat and re-put my original equations down here. We're going to check the 8, -1. So in the first one, when we substitute 8 for x, we get 8 minus y is -1 over 3 equals 8 plus -1 over 2 minus a half. So I get 9/3, which is 3 on one side. On the other side, I get 7/2 minus 1/2. So that would be 3 equals 6/2. And it does. And then in the second one, when I substitute x is 8 plus 2 over 2 minus 4 is equal to y is -1 plus 4 over 3. So that gives me 10 over 2 minus 4, which would be 5 minus 4 or 1. On the other side, I get, let's see, -1 plus 4 is 3 over 3, which is 1, and it checks. Everybody okay with that one? I think that's one of the ones where its bark is worse than its bite. And do you notice it takes a little bit of work to clear the fractions, But once you have the fractions cleared, you get a much easier system to work with. That one all right? If so, next one that I want to copy and paste. Says through the linear function, f of x equals mx plus b, f of -2 is 11, and f of 3 is -9. Find m and b. Honestly, we've already done this question. Let's just look a little bit different. Is everybody all right? This would be the equation of a line. And over here, this is saying that when x is -2, y is 11. And this is saying that when x is 3, y is -9. And so basically, what we've got here are 2 points and we want to find the line. Last unit, we did that by finding the slope between the points and using the point slope formula. Let's approach this as looking at a system of equations. If f of x equals mx plus b, when I use this first one, f of x is 11 when x is -2. Or I get 11 equals -2m plus b. The second one says f of x is -9 when x is 3. Giving me -9 equals m times 3 plus b, or -9 equals 3m plus b. And so now we're going to solve the system. In either equation, we could go through and solve for b and substitute. But let's go through and let's use our elimination. Let's eliminate b by multiplying, let's say, the first equation by -1. That would give me -11 equals 2m minus b. The second equation I'm going to leave alone. -9 equals 3m plus b. When I add the equations, I get -20 equals 5m. And so dividing, I get m is -4. Then to find b, I'll substitute. If I look at the 11 equals -2m plus b, I get 11 equals -2 times -4 plus b, or 11 equals 8 plus b, and subtracting, I get b equals 3. And so if m is -4 and b is 3, my solution is f of x equals -4x plus b. Oh, no, not b. I apologize. We said b is 3. F of x equals -4x plus 3. Different approach to finding that equation through the 2 points. What do you folks think?
All good.
Okay. Then the rest of the questions that we're going to look at are applications or word problems. And my suggestions are to first read carefully. Know what you're looking for. My second suggestion is to make sure that you define your variables. Some people look at those as let statements. If appropriate, draw a diagram. Then you're going to write equations to fit the situation. We'll solve. But then with these, you always want to check in the original situation. Go back to those original words when you do your check. Because we could have solved our equations great, and our checks would work in our equations. But because we made up the equations, we have the right solution to the equations. We want to make sure we have the right solution to the situation. So, does everybody have that down? I'm going to go and pick my first, which is probably the simplest of the word problems. And it tells me that 3 times the first number decreased by a second number is 1. The first number increased by twice the second number is 12. Find the numbers. 3 times the first number decreased by a second number is 1. The first number increased by twice the second number is 12. Find the numbers. We're looking for 2 things. So let's let x equal the first. And for lack of originality, let's let y equal the second. For my equation, 3 times the first. Let's see, if the first is x, that would be 3x. Decreased means I'm going to subtract the second. Is always turns into my equals 1. For my second equation, it says the first number. Well, the first number is x. Increased means add. Twice the second means I'm going to multiply the second by 2. 2y equals 12. And I've got my system. How would you like to solve the system? Do you guys want to use substitution or do you want to use elimination?
Elimination.
Elimination. What do you want to get rid of, the x's or the y's?
The y's.
Okay, to get rid of the y's, what would you multiply that first equation by?
2.
Remember to multiply both sides by 2 and distribute. Gives me 6x minus 2y equals 2. I'm thinking we're going to leave that second equation as is. Adding, we'll get 7x equals 14. So dividing x is 2. And then to find y, I think I'd go back to that 3x minus y equals 1. X is 2. 3 times 2 minus y equals 1. If 6 minus y equals 1. Subtracting, I get negative y equals negative 5. So y is 5. So my first number is 2. My second is 5. If I take 3 times the first minus the second, that's 6 minus 5 or 1. So it checks. And if I take the first and increase it by twice the second, I get 2 plus 10 or 12, and it checks. That one was pretty straightforward in terms of writing the equation. The next 3 are a little bit more involved. Is everybody done with that preceding one? Did I turn the page too fast, or are we good? Then next set. I've got 3 that are kind of attached together, and I thought we could look at the first and the last one. So the first one says, at the North Campus of a small liberal arts college, 10% of the students are women. At the South Campus, 50% of the students are women. The campuses are merged into one East Campus. If 40% of the 1,200 students at the East Campus are women, how many students did each of the North and South Campus have before the merger? Well, we're looking for 2 things. If we let n equal the number at the North Campus, and s equal the number at the South Campus, we know when they merge, there's 1,200 students. So doesn't that tell me that n plus s equals 1,200? So far, so good. Then they tell us about the number of women. Women at the North, 10% are women. So at the North, it would be 10%, 0.10 times n. What do we know about the South Campus? %50 are women. So that would be 0.50 times the number at the South. And we know when they merge at the East, the total is 40% of the 1,200 students. And so that would give me 480. And so wouldn't my second equation be the women from the north plus the women from the south, or 0.1 n plus 0.5 s equals 480? And I apologize, my s and my 5 look too much alike. And so my system is 0.1 n plus 0.5 s equals 480. And n plus s equals 1200. Does that make sense, folks? How would you like to solve that system? Substitution or elimination?
Substitution.
What do you want to solve for? N or S?
S.
S. And so for substitution, would you get that S is equal to subtracting 1200 minus N? And so when I substitute into that other equation, I get 0.1 n equals 0.5 times, I'm sorry, 0.1 n plus, I apologize, 0.5 times 1200 minus n, replacing s with what it equals, is 480. Distributing, we get 0.1 n plus 600 minus 0.5 n equals 480. Or 600 minus 0.4 n equals 480. Subtracting the 600, negative 0.4 n would be negative 120. And dividing by negative 0.4, we get n is, what is it? 300? Then because n plus s equals 1200, when I substitute that 300, I'd get s equals 900. And then for my check, 10% of the north would be 10% of 300 would be 30 women. And 50% of the south would be 0.5 times 900 would be 450. And that gives me my 480 women in a check. Thoughts? Any questions? If not, I'm going to turn the page. And now I'd like to look at, not the first problem bit list, with the last one. Last one says a new restaurant is to contain 2 seat tables and 4 seat tables. Fire code limit the restaurant's maximum capacity to 56 customers. The owners have hired enough servers to handle 17 tables. How many of each kind of tables should they purchase? This time I'm going to ask you guys to tell me what to do. What are we looking for? And I apologize. I think seasonal allergies, usually at least once a spring, I get laryngitis, and I think it's starting today. Hopefully, hopefully I have enough voice for the rest of the week. I hate it when it happens. It just comes on me. So I'm sorry. I feel like I sound like a frog.
I'm very seasonal as well.
Yeah. So what are we looking for here? How many of each type of table?
Yes.
So can I let T equal the 2-person table? And F equal the 4-person? We've got 2 variables, so we need 2 equations. If they can have it 17 tables altogether, what would that equation look like? The total of the tables, T plus F is
17.
17. And if they can have 56 customers, how are we going to come up with an equation for that?
$56 divided by 2.
Tell me why you're dividing it by 2.
Lucky guess.
Let's put a little thought into it. Each of these tables, T has 2 people, right? So wouldn't there be 2 people for each of those tables? And wouldn't each of these tables have 4 people? And that adds up to our 56 customers. Does that make sense?
Yeah.
Eliminate or substitute? What do you guys want to do?
Let's do substitute.
Okay, what do you want to solve for?
T.
T. So over here, we get subtracting T equals 17 minus F. So substituting, we'd have 2 times T is 17 minus F plus 4F equals 56. Distributing 2 times 17 is 34 minus 2 times F plus 4F is 56. So what is it? That's 34 combining minus 2 plus 4 would be plus 2F is 56. When I subtract 34, I get 2F is 22. So dividing F is 11. So if T is 17 minus F, 17 minus 11 is 6. Four people at each of 11 tables would be 44 people. Two people at each of 6 tables would be 12 people. And we've got 56 people. So it checks. Does that seem doable, folks? If so, last example that I'd like to look at is the most challenging. If everybody has it down, I'm going to go snag it from that other page. Get a new page. It says when an airplane flies with the wind, it travels 800 miles in 4 hours. When an airplane flies against the wind, it takes 5 hours to cover the same distance.
What you mean?
Go ahead.
I wasn't done with the last slide.
Oh, I'm sorry. Thank you for letting me know. Tell me when you're done.
Yeah, I'm done.
Sorry about that. Thank you for letting me know. The airplane flies with the wind. It travels 800 miles in 4 hours. Against the wind, it takes 5 hours to cover the same distance. Find the plane's rate in still air and the rate of the wind. There's 2 things that we need to have as background knowledge before we look at this. First, is everybody familiar with the idea that rate times time equals distance? I don't know about you guys, but whenever I drive for an extended trip, I'm always thinking to myself, okay, if I can go 70 miles an hour for 2 hours, I go 140 miles. And I keep, those relationships in my head, trying to figure out how, far I can go or how long it'll take me. Is everybody familiar with this idea that the rate times the time equals the distance? Now here we're looking for 2 things. If P is the plane's rate, and the other thing we want is the wind. If W is the wind speed, the other thing that we have to think about is if I'm going with the wind. If you're going with the wind's pushing you along, you're going faster. So with the wind, it would be the sum of the 2. And if I'm going against the wind or into the wind, well, when you're going into the wind is slowing you down. So the rate would be the difference. Does that make sense? Think of the homework, there might be a question similar to this, but you've got a boat in a river. And has anybody gone boating or kayaking in the river? And when you go with the current, you go really fast because the current is pushing you. And when you go into the current, you go, well, I don't know about you guys, you're probably stronger rowers than I, but when I go into the current, it's really slow and laborious because the current is pushing against me. And so when we're going with it, we add the two rates, and when we're going against it, we subtract. So putting those pieces together, when I go with the wind, my rate times my time equals my distance. And the rate is the sum P plus W. The time with the wind is 4 hours, and that's 800 miles. So that's 4P plus 4W equals 800. If I'm going against the wind, when I look at that rate times time equals distance, the rate is P minus W. The time is 5 hours. And we're told the distance is the same, so that will still equal 800. And I get 5P minus 5W equals 800. And because I sound ridiculously hoarse right now, I'm going to shut up and ask you people to solve that system. 4P plus 4W equals 800. And 5P minus 5W equals 800. And tell me what you get. It's not 90, that's 180. My arithmetic is off, I'm sorry. Did anybody else get that the plane was going 180 miles per hour and the wind was going 20 miles per hour? Yes, no, maybe.
Yeah.
Yep.
Yeah.
Great. Then that's all we're doing with systems. Try to get a good look at the systems problems. And, if you have questions, bring them on Friday. Otherwise, I think I got everybody in attendance. So have a great day, you guys.
Have a good day.
And bye-bye.
Have a great day.
You too.
Everybody have a good day.
Bye-bye. Bye.